In this question, we're asked to rank several compounds in terms of their pH. And we're given some information, such as the Ka of a couple of weak acids and the Kb of a couple of weak bases. And before we get into actually determining the rank order of the pH, I want to talk a little bit about the Ka and the Kb. And I want to do that first for HCN. So if we have HCN aqueous plus H2O liquid, we get this reversible reaction, and it's a weak acid, so the reactants are favored, between H3O plus aqueous and Cn minus aqueous. And if we were to write the Ka expression for this, it's products over reactants. It's an equilibrium constant expression. So it's the concentration of H3O plus, concentration of Cn minus, over the concentration of HCN. Again, we don't include water, just like in an equilibrium constant, because it's not aqueous, it's liquid. So basically here, we have products over reactants. So if we look at these Kas, the higher the Ka, the higher the concentration of H3O+, the stronger the acid. So in this case, hypochlorous acid has a larger Ka than does hydrocyanic acid. So this is a stronger acid, and therefore would have a lower pH, because acids lower the pH of a solution. Let's look at the Kb in the case of aniline. So if we have C6H5 NH2 aqueous plus water, and in this case, this is a weak base, so it's going to take a proton away, and we end up with C6H5 NH3 plus H, excuse me, it's usually written it this way, OH minus, aqueous, and I forgot an aqueous here and a liquid here. We can write the Kb expression for this, and I'm just going to move it up. Kb equals products over reactants, C6H5NH3 plus OH minus over C6H5NH2. Same thing here. The higher the Kb, the stronger the base. So in this case, this has a higher Kb than this, so this is a stronger base than this. Remember that when you're dealing with negative exponents, the smaller the negative number, so negative 8 is a larger number than negative 10. So that's basically how it works. Now that we have an idea of what the Ka and the Kb are telling us, we can go ahead and try to solve this problem. Well, the first thing we want to do is identify what's actually in solution. In this case, we have Na plus and Br minus. So the ion we care about here is Br minus as far as pH goes. Sodium is just kind of a spectator ion. In this case, bromide is as well. The bromide, Br minus, is the conjugate base of HBr. HBr is a strong acid, so Br minus is a weak base. And when you add a weak base like Br minus to solution, it's such a weak base that you essentially end up with a neutral pH when you do that. How about in the next case? What do we have in solution? We have HONH3 plus. This is the conjugate acid of hydroxylamine, a weak base. So this is a strong acid. Strong acids have low pHs. Well, what do we have in the next case? We have C6H5NH3 plus. In the other case, Cl minus was the counterion. Here, Br minus is the counterion. Well, this is the conjugate acid of an even weaker base, because this is even a weaker base than this. This is a larger number, so it's a stronger base. This is a higher number. Excuse me, this is a larger number. This is a smaller number, so it's an even weaker base. So this is an even stronger acid. So it has even lower pH. And in the last case, we have NaClO. So this is a source of ClO minus. This is the conjugate base of weak acid HClO. If this is a weak acid, this is a relatively strong base, and strong bases have high pHs. So our goal here is to find the one with the lowest pH. Well, the lowest pH is going to be the strongest acid. So I have here stronger acid, but it turns out this is the strongest acid. So this is the lowest pH, followed by another strong acid, followed by something that's around pH around 7, neutral, followed by something that's a strong base, which is going to have a high pH, making this number 4. So what you have to do is identify whether you have the weak acid or the conjugate base of a weak acid, or a weak base or the conjugate base of the conjugate acid of a weak base, and then you can identify whether you have a strong acid, strong base, weak base in solution, and then you can determine the pH based on that information. This is a fairly complex question.